All right, let's solve for the hypotenuse of some Pythagorean triples. A triple is just a right triangle that has all integer values for the side lengths. So let's look at this first one. This is got a 3 and a 4 that are the legs of this right triangle, and this angle always crosses the legs. Okay, so let's write out our equation. A squared plus b squared equals c squared. And I'm going to label a as 4 and b as 3. And then again, this points to the hypotenuse, so I know this is the longest side is c. And let's go ahead and plug it in. So if a is 4, I've got 4 squared, and if b is 3, I've got 3 squared, and that equals to c squared. And 4 times 4 is 16, 3 times 3 is 9, and 16 plus 9 is 25, equals c squared. And now I need to take the square root of both sides. The square root of 25 is 5, because 5 times 5 is 25. And the square root of c squared is just c, so this is my answer. My c is equal to 5. Okay? All right, let's try this next one here. Again, the right angle crosses the legs. So I know those are my legs. I can go ahead and label these already. I'm going to label this one as B, and this one as A. And this points to my hypotenuse always, so I'll label that C. And now let's go ahead and write out the theorem. We have a squared plus b squared is equal to c squared. Right? So if our a is 7, that's going to be 7 squared plus b is 24 squared, and that's equal to c squared. And 7 squared is 49. 24 squared is, I had to work this one out, by the way. I don't know this one off the top of my head. 576, and that's equal to c squared. So now we're going to add these together. Let me do this over here. 576 plus 49. That's 15, 7, 8, 19, 11, 12, and 625. That's 625 equals c squared. Now again, I need to take the square root of both sides in order to get my answer. I do know square root of 625 is 25, and that is equal to the square root of c squared, which is c. And this is my answer. C is equal to 25. I've got one more here. I'm going to mark my right angle crosses the legs. So I'm going to label this one as A and this one as B. And my right angle points to the hypotenuse, which is the longest side. I know I'm being repetitive, but I want it to sink in for you. Okay, so we're going to rewrite the Pythagorean theorem. A squared plus b squared equals c squared. We have a is equal to 6 and b is equal to 8. C squared. So 6 squared is 36 and 8 squared is 64. That's equal to that. And 64 and 36 is equal to 100 equals c squared. And we're going to take the square root of both sides, and I get 10 is equal to c. And that is my answer. Now, there's one more thing that I want you to see. This is a 6, 8, 10. This one is a 7, 24, 25. And this is a 3, 4, 5. So if you look up here, I've got this table up here, and this table goes on to infinity and beyond. These are triples. These are Pythagorean triples. This first column are primitive triples, meaning I haven't multiplied, I haven't used any kind of factor. This is the lowest terms these can be in. But on this second column, if that didn't make sense, hopefully this will, I've just multiplied each of these by 2. So like I multiplied 3 times 2 to get 6, and 2 times 4 to get 8, and 2 times 5 to get 10. And then I did the same thing. I multiplied 3, 4, and 5 each by 3 to get this one. And why am I pointing this out to you? Because you're going to see this one a lot. You're going to see this one a lot. And you're probably going to see some variation of the rest of them. But it's nice to know that if you're not sure, like when I see a 3, 4, 5, I know this is 5. I don't have to do any work at all because I know it's 5. And if you forget how to do it, and if you know this 3, 4, 5 triangle here, then you can work that one out and then figure out the pattern, and now you know how to do the rest of them. So there's a good reason to memorize this one at a minimum. All right, so I hope this helps, and I will see you in the next one.